Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today we're going to do a little troubleshooting. I'm going to kind of walk you through a process that I use, and I think I've helped train other people and to kind of follow some of these techniques. And you guys, I'm sure there's some experienced people out there that have some great ideas. So comment below, please. But anyway, we have this Fosi amplifier that I blew up. So we're gonna take a look at this, okay? And I guess to start with, I just want to say you kind of approach it like a forensic scientist. You come up on a crime scene and you want to take in all the data you can, because you never know what evidence might help you later. So the one thing I noticed when it first happened is I saw a blinking light on this power brick that powers it. Okay, and honestly, I couldn't remember when I first started powering it up whether it blinked as a normal thing or not. But I turned off the switch, it kept blinking. So, okay, so is that normal? When I unplugged it, it stopped blinking. So, yeah, so that seemed like this guy was shorted and this was in fault mode. It was hiccuping. It was trying to restart, and then it would light up, and then it would say, oh, problem, and it'd keep on doing that. That's kind of a hiccup mode. And yeah, it just protects the power supply from hurting itself, but it also protects the device that's blown up, that it doesn't keep on pushing current through a shorted input or something like that and just keep on frying, causing more thermal damage. So it's nice to have a power supply with current limit, with overcurrent protection. Okay, so that worked. That was great. Now this guy's capable of what, 4.5 amps average. So peak current, it's probably a little bit higher than that. So yeah, you don't want that to continuously go through your device. So it's nice that that thing shut down. So if this device, if something failed in here, like say that Class D Amplifier chip, and it's sucking a lot of current beyond what that guy wanted to provide, it would go into that mode, that hiccup mode. So that seemed good. So what would we learn? That guy's probably good. We'll check the voltage here to make sure it's still putting out the proper voltage. This guy here, the switch, it didn't seem to mechanically break the connection from the power input to whatever failed. So that's kind of sad, because you think that it would. There's some switches that are soft switches, the little push button switches. Some of those are mechanical, but a lot of them are just soft switches. They're not soft as in soft touch, but soft as in software. They'll go to the enable pin on a chip that controls the power, and it'll shut down the display. It's kind of smart, and it'll shut down the things it's supposed to shut down to conserve power. But it's basically in hibernation mode. It's in sleep mode until you hit that switch, which has power on it, which means it's probably 5-volt power or something like that. And you hit the soft switch and powers up. So the spectrum analyzer that I've been using, I'm going to show that some more videos. It has a soft switch up front, but back by the power cord, it has a mechanical switch that you can turn it off, which I like mechanical switches. And the spectrum analyzer is a precise, kind of a precision instrument. It's not cheap. So they do that to protect it, take it offline, so that maybe it's not putting noise out into the, it's switching power supplies, not putting noise into the circuit, but mostly it's to prevent any surges or anything from damaging the thing. So it's a nice thing to do. And what we learned on this is this doesn't seem to be a mechanical switch, or there might be just some portion of the input circuitry that was damaged, and then it breaks it from the other part of the circuit, which, I don't know. So we'll find out that. So that's one thing. There is a little LED on here, and it was faced, kind of turned sideways, so I didn't notice that was on or off. That would have been nice to know. Using your 5 senses, right? Your vision, your touch. I did feel it, and it was hot. So, okay, it did heat up. Okay, I wasn't going to taste it. so we can throw the taste one out. So I did come closer. I didn't really smell anything right off, and I came a little close, and I didn't see any smoke coming out of it. So there's your 5 senses. But I did, when I got up close, I could smell semiconductor. It smelled like something burned, and I was like, oh, geez. So yeah, but I did see when a waveform well, let me say this. I didn't see the waveform I expected. So that's what started me looking at it like, oh, what's wrong? And then I reached over, touched it. So, yeah. So at this point, I'm going to bring the camera over here. We're going to take the ohm meter. We're going to put this in continuity mode. And we're going to check for shorts. We're going to check to see what we can see at the pins. So, so first you do that kind of visual, the 5 senses. Well, let's say 4 senses. We'll throw taste out of it. Anyway, you do all those things, the inspection kind of things you can do without touching it, and I mean, except for filling it, but I mean, without opening it. And then after that, do a continuity check. Check it out, and we'll go from there. So after the continuity check, then we'll open it up and we'll inspect the inside, okay? And I'll tell you what, as you go along, it's good to take photographs and take all your hardware, put them in a little bucket. I have a bunch of these little ice cream buckets I put stuff in. And it's nice because, like right now, I've got it right here on the mat because I don't know what I'm going to find, and I might put it right back together. So I started disassembling it. Actually, I lost some footage. So I did disassemble it, and I'm going to kind of go backwards again and show you. But if I have to order parts and wait, something like that, then I'll put all the parts in a bucket, keep them all safe, put all this stuff in. I got a larger plastic little bucket that I put things in. So I'll put the bucket of hardware and, everything in a kind of a shoebox size. Kind of like that. Bunch of parts, a heat sink, bunch of parts in a bucket like that, okay? So, yeah, and then I'll store it until the parts come in. But let's jump inside this thing and take a look. And I'll kind of walk you through my troubleshooting techniques, okay? All right, thanks. Let's come over to the bench. All right, guys, here's our stuff. Here's a power brick. I am going to just go ahead and test that right out of the gate with this Klein Tools meter. And do I have it on DC? Nope. Okay, let's just check that right to begin with. Yeah, we got 24.6 volts, so that thing seems to be really solid, really stable. So we're going to get this out of our hair. That seems to work. And we'll focus on this stuff. Okay, so what we want to do, you can see I've already opened it, right? And by the way, I've got these tools here. Let me just talk about that. This Pick Quick, it's a Canadian company. When they came out with these tools many years ago, I happened to be in an electronic shop, saw them on the bench, bought one, and loved it. And then I bought this kit. It was returned to Amazon. So, see? So, thanks for giving it a second life. Now, it was kind of partially open. I opened it up more, but then I lost that footage, like I said, when I opened up this unit. But this guy here, I also love this. And has a, ratchet, and you have to pull this down, release things, but you got 2 heads, and so you got lots of bits in here. But this guy was great. It was able to take the screws out of the front of this perfectly. And I just happened to have this bit in there. So I reached for it and I was like, wow, this is just what I was using on my Class A amplifier. So that was great. So then I went to the back, and of course they used a different head. I don't know, it's always kind of frustrating, right? And it was a teeny one. I did not have one in this tool, Work Pro. So I'll put a link down below. Appreciate using those links. Doesn't cost you anything extra. But anyway, so I grabbed this guy, and sure enough, I could see this little driver right here had some small bits, and I got a small, so I got a small Phillips in there right now, right? And that's because, where is it? All right, just rolled off underneath something, but here it is. So yeah, this is a little Phillips, and this guy was sitting right here. So I had the 4 screws plus this one up here, which I'm kind of, I was wondering, well, why is there a screw up there? It's probably holding the board, this board that these guys are mounted to, up against the back plate. So then there's these washer and screw that held the antenna in place. That's where this guy plugs in, okay? So that's for the Bluetooth. And then we have these. Now, I also started removing the front plate. Well, actually I did, okay? But I've got one screw in there just kind of hold it in. Now, the thing is if I pulled all the knobs off, took the bolts like this, the nuts off of these, I could slide the board out. But as I was just opening up all these things to look at things, okay, now here I need the little driver to take this guy off now. So the way that works, you just slide them in like that, and they're all captured, and it's nice. I love these tools. I think that black one right there is the one I bought originally, and it's in a tool bag somewhere, so I have to find that. Whoops, that's a little too small. So yeah, all the ones in this kit were too large. So let me pull out the biggest one in this handle. And then I got 2 more sizes. So I'll put links in my thing for these as well. Yeah, there we go. So there we go. We're going to take that off. But you know what? Just before I finally take that off, let's go ahead and put this in continuity mode. Okay. Got the little beeper sound. So, okay. So there we go. Okay guys, so now I have this in continuity, and the first thing I would do before I take it all apart is I'd check continuity, and I'd go to this speaker output, it'd be open, this speaker output, be open. Now the thing is that's not really true, I gotta show you, but that's what I normally do. And I would even test the inputs just to see if the input of an op amp was shorted. And that checks okay. That, large impedance. So I would check all those things, okay? Now what I've done, like I said, I've already taken this apart, but I really like these tools. They're just, I like having, these were some of the first ones I found with tools in the handle. Now pretty much all of them have it. But okay, so there's that, okay? Whoops, let me take off the other one. Okay. All right, so see, that's why I couldn't read it in continuity, because I've already unsoldered this. I've already removed it, and I could have removed all those knobs in front and pulled this whole thing out. But the reason I decided to do it this way and leave all that intact is the solder jobs on this didn't look great, so I wanted to redo them. And here, let me show you. All right, guys, so see these. Now, I unsoldered them, so, I've already, as part of the forensics, you don't know, whose footprints are on what, right? Because I've already stepped all over the evidence. But what I can tell you is that big old glob, that was actually there, just hanging off. So if somebody soldered those wires on in this orientation, which is probably the way they did it, as this unit sitting up like this, they probably didn't see all the solder forming underneath the wire. So, but you want to inspect your connections well so you don't have something like that. Now that's such a big old glob. Whoa, it actually did break off. When I first pushed it, when I pushed it on, before, it didn't break off because it was on there so well. But now, yeah, that big old solder glob was already on there. I didn't put any additional solder. I just used flux and removed this. So, all right, I just want to point that out. And then, let's zoom out a little bit. We'll keep kind of zoomed in. So, once I got that, then I was able to pull this out. Now, here, since I already got this driver set up, I'll just go ahead and take that guy back out. And you know what? before I actually pull the board out. Like I said, it's kind of, I'm telling you to handle this like a forensic scientist, right? But at the same time, I've already pulled this out and lost that footage. So some of what I've already done has been lost, and so we're kind of going backwards. But you know what? Before we slide this out, let's just go ahead and we'll put this back in continuity in beeper mode, right? Move these out of the way. Okay, so I got that back in continuity mode, right? Got the little buzzer thing. Okay, so there we go. Now what we want to do is come to this speaker output. Now see, when I go to this ground and I touch ground, that's shorted ground, okay? This one's not. So the one that's not, if I also go to ground and go to the red one, no connection. If I go to this red one, it's also shorted. But let's see how many ohms it actually is. So it's pretty low ohms, okay? So if I go between these, obviously they're going to be shorted, because so that chip output is just totally shorted. Okay, now what I mean totally shorted is, let's turn off the beeping because that's kind of annoying. Let's just go to ohms, and I'll try to hold it steady. Yeah, so that's 0.4 ohms. That's totally shorted. The reason I say that is because, continuity meters, I mean, continuity mode, it's like 20 or 30 ohms or below 50 ohms, something like that. You got to look at the spec on each meter you have to know what it calls continuity. So that's 6.45 meg. Hey guys, one thing that happens when you're troubleshooting is you get these little slivers sometimes. Little metal sliver. So I'll put that up here. But yeah, that's why you want to keep a clean bench. I try to keep a clean, actual work area fairly clean. But even with this, when you're taking things apart and that, sometimes you get little metal slivers. So yeah, anyway, just side note. But all right, going back to the checking. So we saw ohms there, right? And if I go to the ground to this guy, it's like 3 meg ohm. Go to the red one, it's like 3 meg ohm. And again, short. And if I go to the Bluetooth ground, it's dead short. And if I go to the power supply ground, it's dead short to, well, is it? Yeah, it's dead short to the RCA as well. Okay, so the speakers should not be there in that bridge mode. Okay guys, so then what we're going to do is just slide it out carefully, okay? And you want to check, make sure nothing falls out. And then first, just look inside the box. See if you see any burnt, scorch, or smoky marks where it's obviously something burned. And, when I look down here inside the box, you can't see it because it's just very faint, but it does look like a little bit of smoke or something. It might be my imagination, but yeah, anyway. So look inside the case, because lots of times you'll take off a case like that and you'll see a burnt mark on top and a burnt mark over here, or just heated marks where maybe it didn't fill yet, but you can see where heat's raised. Okay, so here, let's zoom down here so you can see this board. Alright, so we're looking at the board and I don't see anything obviously burnt, and I would use this and go real close and just look around, see what I can see that looks burnt. Let's move this antenna out of the way. This antenna is kind of cool, by the way. It's got the little, I forget what they call that little RF connector right there. That's pretty cool. But alright, anyway, back to looking. Now, so yeah, you just inspect it, visual inspection. You might do the sniff test too if you're looking around, but what I suspect, underneath here we're going to see something burned. So it's not a super large heat sink. It would have been nice to see the fins come up a little higher, because you know, there's still space above them, but just to add some more surface area. But yeah, the capacitors look fine. The first thing you look at is semiconductors, like this part here, that part here, any diode, anything, you know, basically black plastic in a lot of cases is you know, there's some diode or some semiconductor. This is the Bluetooth module, so I'm sure that that's totally fine. That's low voltage. Op amps, input op amps over here, input power supply over here probably. These are the output inductors, and the little capacitors down there are LC filter output. And I was looking at those resistors down there, sense resistors probably, for current sense or something. They look fine too. So yeah, no visual damage from there. And as I flip it over, the backside, very clean. No components, but also no traces burned. So you want to look for traces to see if you see any trace work that's burned, heated up, scorched, you know, smoky, that kind of thing. Sometimes even vias, you'll see if it's something burned real bad, it'll come right through maybe some of the vias to the top side of the board. You'll see some burn marks, but yeah, everything looks pretty clean. So, all right. I'm also just looking at the quality of the solder work here too. As I look, it looks okay. All right. So far, the only quality issue I saw was the soldering of these wires to the output poles. Everything else looks like nice quality work. 2021. I did buy this. I did mention in my first video reviewing this, I bought this a couple years ago. You can tell it's 2021-018. So is that January 8th of 2021? And this is version 002. I don't know if they sold a version 001, but yeah, so they have that version on the board. Yeah, I don't know if you can make that out. Okay, things look good. So the next thing I would do, oh, by the way, I want to point out these probes I bought. These aren't the probes that came with this. You can kind of tell the handles are dirty. I use them a lot. These are silicon cables, and I believe these are like $10, $9 to $12, something like that. They come with a kit, little plastic box with a bunch of different pins you can put on this. There's a long set that are pretty nice, and then I put this set on because they're kind of do everything, and it's nice because they're long and narrow, but the longer ones are actually good for certain things. But anyway, so I really like these probes though. They're nice soft grips and just really nice. So anyway, just wanted to point that out. So what we're going to do is I got this in continuity, right? And I'm going to start here at the input because something's shorted. So I go to the middle tab of this part here, and it says Q, so it's a transistor. So the middle leg is the tab. So see, it works, right? But now I go to this outside leg, and that's 0.2 ohms, so that's short too. Okay, it's not, that's 182, that's fine. Let me go from outside to outside. 180, same thing, 182. And that makes sense because, so two of those pins are shorted. Now, is it this guy that's died, or is it a sense resistor between them, or a diode or something like that? I suspect this guy here died. Now, what I suspect is this is reverse voltage protection. It could be a voltage regulator right here at the input, maybe regulating to 24 volts or, you know, steady 24, I don't know, just for over voltage spikes. But I doubt it. This is probably reverse voltage protection. But anyway, let's check out, and there's a diode right here, so we can check that out. Okay, that's not shorted. There's a little transistor here. All right, got a little closer so you can see that part up here that's shorted, right? Tab to outside leg. That's just shorted. And the diode right here is not shorted. I'm going to put this in diode mode in a moment, but right now I just want to see if there's, you know, what's shorted. It's probably that guy. This little transistor is fine. So now here's something else. This is All right, guys. The one thing over here is a U5. It's voltage regulator. It's LM7805, so it's 5-volt regulator. So if I go to that tab, outside pin's okay. No, it's not. It's shorted. 2.6 ohms. Sorry, trying to get around the tripod leg without bumping the camera. Okay, the other outside leg looks okay, but okay, so that 5-volt regulator looks like it's gone bad too. So when this, I'm sure the Class D chip underneath this heatsink's dead. When it died, it took out the 5 volts and this, so it drew enough current through it that if this is a reverse voltage transistor up here, then it drew enough current to take that reverse voltage transistor out, because that should have been just on, and it was in the milliohms, so it's kind of interesting that we've taken it out. Here, all right, guys, so at this point, what I want to do is I want to pull up the data sheet of this FET here, this 9520, and I want to show you that this is the source. So the power comes in through this pin, and it goes up to the source, okay? And then the drain is over here, so it goes out to the plus of all these caps, okay? So these caps store the voltage that's coming in from this input, okay? So these caps are here, and what's in between them is this transistor. So this looks like it is a reverse polarity transistor. So some of the issues, this design is not the way I would have done this. I have a more efficient way of doing these reverse polarity protection circuits. This guy's not very efficient. It's almost half an ohm. So if you really are having, 4.5 amps go through here, it can't do it, because this guy's also rated for what, about 4 watts. So if you have 2 amps, I squared R, 2 squares 4 times that is 2 watts. Okay, so 3 amps is 3 squared, 9 times that is 4.5 watts. So you can see that you're only around 2 to 3 amps continuous in here before this guy is going to overheat. So that's one of the first problems I have with this design. The other thing is these capacitors. So if you can see, these capacitors, they're only rated for 25 volts. That is crazy. This design, not only can it put out 100 watts per channel, or max power, I guess that's what they state. So you could say average power is 50 watts maybe. That's still not to be determined. I mean, with the power supply feeding it, you can't do it. The thing is there's a couple reasons. First, you have to have enough current, you have to have enough voltage so you get the voltage swing. So I still, now that this guy's been, since I blew this up, I can't really test that for sure, because I'm not sure. So these are 25 volt caps, 1,000 microfarads, so that sounds good. There's 4 of them, 4,000 microfarads. That's not bad. But, I just think that you can't get the kind of power out of this that you'd want to because of the design, because this transistor, the RDS on, is just too high. These capacitors really need to be 35 volt caps, so they would be 70% used, so that's a 70% derate. Well, which is kind of funny, because you're using 70% at that point, almost 70 if you have 35 volt caps. Right now we're almost 100%. And now some audio people say that's okay, but it's not. All right, that's also 25 volt rated. That's probably the input to this voltage regulator. And this voltage regulator, I'll show you the data sheet on that too. The short, what seemed like a short, is probably just the input to ground. Okay, the output. So this guy's probably okay, this little 5 volt regulator. He has a 10 volt capacitor on the output. So that is appropriate. That sounds good. I'm going to try to reverse engineer this circuit here. And so this little transistor, I'll show you the data sheet of that right now. It's just a little small guy, but I'll show you the data sheet. Okay. So what we're going to do is we're going to try to come up with this circuit to see what it's actually doing. I suspect reverse voltage protection, but all right, so now let's go on. I looked at this circuit a little closer. All right, guys, so the pin up here is tied to plus voltage, 25. This pin is tied to ground, so this one gets toggled between plus and ground. And this center pin is going up into this circuit, so it's powering this, I guess. Okay, and not really sure what's going on with all this stuff, but on the other side of the switch, the center goes to this via right here. Okay, there's trace coming out here. When you follow the other side of the board, it goes up to here, and it kind of jumps all around, but it goes up to this IC. Okay, so it's probably the enable. Then one side of it is ground, and the other side is probably some voltage up here or something. So anyway, this guy is tying this to ground, which pulls this down to ground. You know, the IC here, I'm sure it's some enable pin. Okay, so it really is just a soft switch. All right, so anyway, yeah, this switch is just enabling this. The power comes in, power's always here. So I'm not a big fan of that. I mean, especially when you're going out, I just like to see this tied to the input. Here's what I suspect. The reason why they did that probably is so that the voltage is here and it's present. So this guy here just enables, disables, so you don't get those thumps. The circuit's controlled, power's there, so things are operating, and this just enables the output. So you don't get a thump, all that kind of stuff. I'd rather see it tied to this and some sequence of power coming in to stop that thump and do it that way. But anyway, this is the biggest problem. The capacitors that are not rated for the voltage, this guy here not rated for the power. So we're kind of running into some interesting flaws in the design, I believe. I'm going to take this heatsink off. All right, just zoomed out a little bit. But anyway, this guy here just has one screw. One thing to point out, it does look like this is a ground plane, so this heatsink is pulled to a ground plane. All right, so let's see what we got. And right away, I can see some burn marks on the heatsink. Yeah, so we got some scorch marks. This over here, I don't see anything burned. The other thing, what I'm looking at is the thermo paste. I don't see a nice thin coating. Now, it could be because it got so hot it kind of boiled out. Now, this over here is too thick. You want to put on a nice thin coating just to fill in the air gaps. You want metal to metal as much as possible, okay? Let's just put that out of the way. And let's zoom in on this board. All right, so yeah, it's pretty apparent that right through here it's burned. This chip looks okay. The board doesn't look damaged, so that's a big plus. It just looks like this part here died. And again, the paste, even if it just doesn't look like a nice thin coat, an even coating on both these chips. Again, it could be because the heat sinks got so hot that it kind of boiled out. Maybe, I don't know. But all right, so yeah, it looks like I need to order a chip. All right, guys, just kind of want to share with what I was doing. First, I thought I was going to try to draw the circuit. This is the little small transistor. It's a PNP. I just didn't draw the PNP in this one. And the source, I was trying to go left to right, but then I kind of got lost, honestly. So I went back and kind of drew the parts where they are on the circuit in here, and then just looked at the trace work and just tried to make all the connections. And I made some mistakes because some of it goes under silk screen, so then I pulled out the meter, I ohmed things. It was kind of difficult because this is shorted across here, so I had to be careful to measure, is it really 0.1 ohms or point, a few ohms. So I could tell the difference between this connection as I ohm things. So after all that, I kind of came up with this, and I drew in the same alignment as the board, you know, power coming into the board up here. And what it kind of looks like to me is that circuit. I didn't draw the values or anything like that. You can see that. But, and this is the P channel FET. Okay, so the source is here, the drain and the gate. I just kind of drew it that way to make it easy. I was going to try to do a nice drawing, but I think I'm just going to go this far with it for now, because it really does look like reverse voltage protection. If you have plus voltage here, what happens is you're going to have plus voltage here, and it's going to turn on this transistor, and he's going to operate, okay? And so when he operates, he's going to pull current through here, and as it pulls current across this resistor, this is from source to gate. So gate is P channel. When the voltage is lower than the source by, you know, a few volts, 3 or 4 volts or whatever, you'll turn on this. Okay, so, and this is a Zener diode, which when I saw the parts, the Zener transistor and so on, I thought it could be a regulator. Like the Zener would be down on the base of this and it'd be regulating the voltage, but it doesn't appear to be that way. This guy here looks like he's protecting the voltage from gate to source, so you can't over voltage the gate on this. That's what that looks like. You got a capacitor to kind of steady the voltage from gate to source. You got a gate resistor, and this resistor right here turns this on when it develops a voltage, when this guy's properly, you know, configured. Now, if you have negative voltage here, it's not going to turn this on, so you're not going to get any voltage there, so there'd be no voltage here, so this guy won't turn on. Okay? The body diode is the cathode's over on this side. So the interesting thing about that is if you put negative voltage, it could go through that, so it doesn't have to be on to pass voltage. So that doesn't make a lot of sense. So anyway, maybe this isn't going to work as well for voltage protection as they thought, or reverse voltage protection as they thought it would have. Alright, okay guys, sorry. I tried to redraw that, try to actually draw a FET in there a little bit. So you got the source, the gate, and the drain, and this body diode's inside the FET. And so, sure, if you get plus voltage, nothing goes through the diode. It has to be turned on to turn this guy on so everything works. Reverse voltage, it doesn't turn it on, but the problem is you got negative going through the diode, so this reverse voltage doesn't work. Yeah, kind of crazy. Huh. Yeah, that's what it looks like to me though. I mean, maybe I drew the circuit wrong, but I don't know. I think I got the circuit drawn, so just doesn't seem like it's gonna work. Hey guys, so what do you think? Let me run down the list and tell you what I think, okay? First, I got to replace that chip, the 3116, obviously. Got to get one of those chips. That FET, whether it's for reverse voltage protection, which it's not going to work for that because the body diode's is going to allow negative current flow. So it might be, the other thought I had is maybe it's for inrush current protection, because it does have that cap to the emitter of that transistor, that emitter resistor. So that could be the RC input that would maybe allow that thing to soft start. So maybe that's what that thing's used for. But that P channel FET has too high of RDS on. I mean, if you have, you can't run the 4.5 amps, you know, this power guy is rated for. And also this guy, that's another issue, is the voltage, you know, I don't think you have the headroom. You don't have the power that you could get if you had a higher voltage regulator, which takes me to another thing. The capacitors, they're not derated enough. They're almost, I mean, 25 volt caps on a 24 volt line. That's just not enough. Now that P channel FET, unfortunately, is going to drop, you know, around a half an ohm actually. Some brands are 0.6 ohms of that FET. So yeah, you're going to drop some volts across that. So yeah, you're down and around, which you don't want. That thing's gonna run. That's crazy to me. You're losing power on that on that FET. So, but anyway, it would drop the voltage, so you'd have a little bit less voltage on those capacitors, which would also show, show why the peak voltage couldn't go as high as I thought it would. So, all right, so I got to replace that FET on the input, get a better P-channel FET that has lower RDS on. A better P-channel FET's probably the way to go. So you got to do that. Change all those 25 volt caps to 35 volt caps, or even maybe 50 volt caps. Now the reason they didn't do that, I'm sure, is because of cost. It costs more, and they're taller. They would be taller, which they would fit. Now, if you couldn't find taller ones and they had to go bigger around, that would be a problem. So then you'd have to go 750 microfarads. There's a thing called CV rating, capacitance times voltage. So you take that 25 volt times 1,000 microfarad, that gives you a value. So if you go, say, 35 volts, you divide that value by 35 volts, that tells you the C that you're probably going to get in that same package. It's just a CV rating. So, yeah, there's that. They need to be replaced. They're just, I mean, it's the audio community that has developed this whole thing called recapping, where people go replace the capacitors. Because when you look at the formula for a capacitor, the life of it, it's the voltage derating, the current derating. If you're not derating, you're taking the life out of those caps. So you're going to have to recap someday. So maybe people think, oh, these are so inexpensive, no one's going to use them very long anyway. So what the heck? Let's just, be chintzy and put 25 volt caps where should have been 35 volt caps, which would have meant they would have been used to 70%. So they would have been a 70% derating is what that's called. It's kind of confusing because it sounds like derated 70, so you're only using 30%, but you're using 70% of the capacitor, 70% derate is how they call it. But anyway, yeah, so that FET needs to be replaced, the capacitors need to be replaced, and the 3116 need to be replaced, and then possibly this guy to a higher voltage to get more dynamic range. Don't really necessarily need a lot of power, but just having that dynamic range, that voltage range. So yeah, hey, who would like to see me test this? I don't think I've ever seen one of these things tested. I wonder if this guy drawing 4.5 amps out of it, if you could do that continuously. At what point it overcurrents, because it did protect itself, so that was nice. But could you do a transient from, say, 1 amp to 4.5 amps without having a voltage dip? At 4.5 amps, is there a lot of ripple on this? If there's not, those 1,000 mic caps on the board, maybe that's not even a big deal. So maybe if you went lower capacitance with a higher voltage rating, maybe that'd be fine. So yeah. If anybody wants to see me test this, let me know, okay? This is going to go in the box with the other stuff. Oh, the hardware, the antenna, all the stuff in there, the small stuff, the big parts in there. And I think I'll put this guy in here too, keep it all together. And we'll wait for me to get that 3116 in where I can repair this. And a new P-channel FET. Have to find one of those. And also the capacitors. I think I have some really nice caps, actually. So there you go. And also here's another thing. If you go to better series capacitors, you get a better CV rating, denser capacitor. And I think I have some really good caps over here. So yeah, we can improve this, make it stronger, make it better. I like to test it the way it was, but yeah, I don't want to waste my time doing that. Got to improve it now. So, all right, guys, let me know what you think. Appreciate you watching. Appreciate my Patreons. As always, 2 thumbs up to those guys. And anybody that hits that super thank you button, really appreciate that as well. Yeah, it's taking a little time to do these videos, but I appreciate you guys being here. And a free way to support the channel is just to give it a like and share it, that kind of stuff. And subscribe if you haven't done so. Maybe you think you've subscribed, and maybe you have, but look down below, see if it says subscribe, because if it does, it means YouTube, for some reason, unsubscribed you. I think that happens sometimes for some reason. I don't know why, but I've heard that that's true. So, yeah, there you go. All right, guys, thanks. Give me your comments below what you think I should do with this thing. And yeah, we'll see you next time.